Hi, this is a continuation of week 3, and we're going to skip the seasons. You can learn about that on your own. There's lots of good YouTube videos out there that other people have done, but I'm going to take a stab at two other topics. I'm going to look at retrograde motion and the phases of the moon, two of my favorite topics. So how could it be an astronomy class without learning about retrograde motion? And once we understood that we live in a heliocentric universe, that's a term that means the sun is in the center of the universe, Helios is the sun, and the Earth and the other planets rotate around the sun, you can understand the concept of retrograde motion. And if you were to define that, all you would have to say is that it's the apparent backward motion of a planet over time. Well, I'm going to show you this YouTube video that is an animation of retrograde motion. And this is something, imagine that you're an ancient astronomer or ancient observer of the sky and you're watching these different planets going across the ecliptic, that path in the sky, and you notice you've watched them each day and they seem to move in a general direction over time, and then one of them wanders and it goes backwards. And this is a mystery that really no one could explain until Copernicus put the sun in the center of our solar system, and the sun with the planets going around, then you could explain it. And so here's a little observation, a little video of it. So we're going to start out. Come on, play. Okay, here we have Mars coming along. You can see it traveling, and the other ones tend to overpass it. Mercury and Venus overpasses it, and then Mercury moves backwards. Show that again. We got Mercury, it moves backwards, and then it makes a loop. So how did that happen? Retrograde motion is all about the apparent position of the Earth and the other planets as we're traveling around the sun. So I'm going to use it for Mars here, where we can have retrograde motion in Mars. The Earth is going to be moving around on the inner track, and it's going to be moving a little bit faster. And so it's going to actually, this will be our observational point of Mars in the sky, and we look out and we see it right here under position 1. Let's say a couple days later, a week later, we're here, we've moved this bar, and Mars has moved this bar, and so it looks here where it's in position 2. Then as we move here, we're looking at it, Mars is here, but then it depends to move backwards here. So it's just all about the relative position. Now it's really moving backwards, and then as we move farther, then it continues to overtake us. So Mars is going to move this direction in our sky through these constellations, but it's all about the relative perspective. So I don't know if that's clear or not, but now you know what retrograde motion is, and you know that it's caused by the relative position of the different Earth and different planets going at different speeds around the sun. And in this section of the video, I'm going to talk about moon phases. You've gotten a chance to look at the different phases of the moon in the last few weeks as you're looking at your reflective journal, but I just wanted to cover a little bit more detail so that you could have some terminology that I've given to you, and it's not just you looking it up. So you know that it takes a month about for the moon to go through all its phases. Here's a beautiful full moon. And here we're going to look at the phases of the moon in its 29.5-day cycle. We'll start with the new moon up here. Is not visible at all. It's the dark of the night sky. You can see the aurora and the stars great because there's nothing in the dark sky. That's because the moon is between us and the sun. So as we spin away from the sun, we're spinning away from it, and during the daytime we can't really see the moon because it's right in front of the sun and it's too bright for us to see it. We'd be blinded trying to see the moon. But we can soon, in a few days later, as the moon moves away from the sun, starts to spin around us, we can see it as a waxing crescent. So whenever you see on the right side If you look into the moon and you see a crescent, this here it is lit on the right, and here it's lit on the left. If it's lit on the right, it's a waxing crescent. It's growing larger. Every day the moon will get a little, the next few days it will get larger and larger, and it will take a week for it to get into the first quarter. Then once it gets past the first quarter and it's past halfway, it's a gibbous. And then in this case, it's a waxing gibbous because every day it's going to get a little larger. It's making a D, capital D is getting larger and larger until it's a full moon 2 weeks after the new moon. Then it's still a gibbous, but we call it a waning gibbous when it has this orientation. And then the last quarter is a backwards D. So if you see a backwards D at any time you see this moon, you know it's a waning, and you know that every day or waning it's going to get smaller and smaller until you have the waning crescent. So anyway, those are the phases of the moon, the terminology that you should be familiar with, and you should really understand why you see this. It's because of the relative position. Like I told you before, when the sun is lined up with the moon, and we're here during the daytime, the moon's over here, and we can see that this is the sun over here. We're really not going to see anything because during the day we're staring into the sun, it's bright. But then when it turns to the right here, we're going to look and see that we've got the waxing, it's getting bigger, crescent moon. And here it's going to take 2 weeks. We have this orientation because we're at nighttime. We're able to see it, or right as it's becoming night in the evening, we're going to look over and see this quarter moon right here in the sky. And it's going to look like a capital D again. It's waxing, growing larger, and then we're going to be able to see the gibbous. And when we have the full moon is when the moon is on the opposite side of the sun. We're able to have all the light of the sun shine on it, and we'll see this full face of the full moon. Again, all the phases have to do with the relative position of the moon, the sun, and the spinning of the earth. So that's the phases of the moon. You should be really familiar with them. Every week you're going to be looking at them and you'll know what's happening in the sky. Something else that's really cool, you can demonstrate this yourself if you go into a dark room and hold a ball. It could be a tennis ball or something at arm's length, and just have someone shine a bright light at you, like a bright flashlight that will blind you as you look at it. Put the moon in front of it and you'll see that it's really hard to see it because you're squinting and being looking at the new moon. Then as you spin and turn, you'll be able to look and see that the light of the flashlight is hitting your moon, and you're going to be able to see all the phases. So go ahead and try it if you can. Show it to your kids. It's really cool. Another thing is that a common misconception that people have, that you really need to know this, is that is there a dark side of the moon? Was Pink Floyd right? Is there a side that's always hot and the side that's always cold because it never gets the sun? Nope, there's not. But we get to see the man in the moon, or the face of the moon, because the moon is locked in a tidal synchronous rotation. And so it actually does one spin every time it spins all the way around a month. This girl is going to demonstrate. Here she is. She's the moon. The light of the sun is behind her, and it's hitting her back, and it's shining up towards the person on the planet Earth here during the day. They're looking at the moon. So what phase is she in? You should know. She's in the new moon phase. And look, what part of her is being lit up? Her back. So her back's toasty warm. Now she's actually going to do a quarter rotation turn as she spins around, and she's going to be looking at us, and when the people on Earth see her, they're going to see her face, just like they could have saw her if they weren't blinded by the sun. They're going to see her face. She does her tidal rotation synchronous movement, and but only half of her is going to be lit up. This half over here on her left arm is going to be lit up, and this half of her face. So she's going to be in a quarter moon phase here. Now she's going to turn a quarter way, and her front is going to be lit up, but we still get to see her face, and now she's a full moon. And here she will be, what phase is it? Is she waxing or waning? You should know this. She is waning. I like to say waning. Waning, and only her right arm is lit up this time, and the right side of her face. as we see her. So hopefully this makes perfect sense, that the moon does a synchronous rotation and we only see one face, but does this girl have a dark face? No. A dark side? No. All parts of her body get warmed by the sun as she makes her rotation for the 1 month. You can demonstrate this at home too. If you have some kids, go ahead and try it. Something else that's cool that you should know is that a full moon rises in the evening. So if you're looking for a full moon, it's going to be kind of around sunset-y, 7 o'clock p.m., which sometimes is sunset in Alaska and sometimes it isn't, but that's generally when we would see the full moon rise. You'll get to know these phases with your constellation, not your constellation, with your reflective journal, and you'll get to look at the moon and you'll get to know it. Well, anyway, that was retrograde motion and phases of the moon. I hope that it's super clear, that you're illuminated on this topic and you've learned something fabulous for your day. And anyway, have a great week, and I hope you enjoy the quiz this week and this video. So bye-bye.